Seriously? Are we going to get all huffy about this? Technically, they are hydronium ions.
Yeah, Alex, how many people know what a hydronium ion is?
Same number of people who know what a proton is.
Yeah, that's precisely 0 people.
Welcome to the Electrochemistry Podcast, where we discuss all things electrochemistry. I'm your host, Dr. Alex Peroff, and with me is my co-host, Dr. Neil Spinner. On today's podcast, we'll be hearing a story about graduate student Lisa. Lisa had just finished her last set of classes she needed to take as a graduate student. The spring semester ended, and she had lots of plans to catch up on research over the summer. She was planning to do some new electrochemistry experiments, but had to perform a routine CV test on her Glassy Carbon Electrode first. However, instead of getting a smooth voltammogram, her voltammogram contained jagged edges and sharp zigzagging and crisscrossing lines. Confused, Lisa took the electrode out of the cell, and while visually inspecting the electrode, Lisa looked in horror as her polished glassy carbon surface had black, jagged spikes protruding from the electrode. What happened to Lisa's electrode?
Whoa. Okay, before we go any further, I have to tell you that I figured out what the problem is going to be. It's trying to get experiments done during the summertime. Okay, go to the beach or like a barbecue. Starbucks has really nice summer drinks. Like, enjoy life.
Yeah, but after I finished graduate school classes, I was pretty eager to start doing research full time. Like, no more classes, just research. But I was so young, so naive. Neil, were you excited to do research once you finished all your classes for graduate school?
No. But then again, I'm not young, naive, or apparently someone who has a good work ethic, apparently. So I told you before, I finished my classes, and then I just sat in Starbucks for like 7 months.
Wait, did you finish your PhD in 7 months?
No. What I'm saying is I finished my grad, like chemical engineering classes, and then instead of starting research like Lisa and you and everybody else, I just sat in Starbucks. Research is for losers.
Amazing. And you graduated summa cum laude in chemical engineering with an H index of 100 in just 3 years. A regular savant.
Look, okay, not everyone can be as prolific as me. And by the way, my H index was 104. So thank you very much. But I mean, who's really counting? Well, Anyway, my incredible and absolutely in no way, shape, or form fabricated graduate school career aside, okay, it appears that Lisa is equally as young and naive as you were during your first summer of, grad research. But while I was enjoying a peppermint mocha, which was a much better choice. But anyway, probably the best thing for us to do right now is to stop judging what is clearly her excellent work ethic and just help her with this problem. So I suppose the first thing to do is to get every bit of detail about her experimental setup.
Yes, that's right. So the working electrode, of course, is glassy carbon working electrode, which was polished the day before. The test solution consisted of a fresh bottle of dilute sulfuric acid, a platinum counter electrode, and a single junction silver chloride reference electrode. And the solution did not need to be degassed.
Okay, and was her counter electrode isolated from the electrochemical cell? Was Lisa using an isolation tube?
No, Lisa was not using an isolation tube. The platinum counter electrode was directly in the cell. Why do you ask?
Well, sometimes the counter electrode will generate unwanted byproducts that you don't want in your electrochemical cell. So an isolation tube is used in those cases. And if you've never seen one, it's basically just a glass tube with a porous glass, often glass frit at the end. And the counter electrode sits in this tube, which is also filled with the main electrolyte. So I guess in her case, sulfuric acid. And so the sulfuric acid is on both sides of this frit at the end of the tube. So the isolation tube separates the counter electrode from the cell while still maintaining contact with the electrochemical system. And most of the time, it shouldn't matter whether an isolation tube is used or not, but sometimes it can lead to a compliance voltage issue.
Gotcha. So there's a pretty good chance she wouldn't have a compliance voltage issue because there is no isolation tube. But I think we now have a better idea about her entire electrochemical system.
Yeah, I think so. So normally with issues like this, I tend to tell people to troubleshoot their electrochemical problems in, a well-characterized system like, ferrocyanide or ferrocene, ruthenium hexamine. It depends on whether it's aqueous or non-aqueous, but something like that. But also, let's just be real. Sulfuric acid, dilute sulfuric acid probably shouldn't be a problem for her, for most people.
Right. The electrochemical system isn't some kind of newly synthesized catalyst where we have absolutely no idea how it's going to respond. And the last thing we want to troubleshoot is some like methyl ethyl kill you molecule with the sole purpose to just destroy your research because your advisor saw it published in Nature.
Yeah, or because they heard it, discussed during some fancy symposium at the latest like academic electrochemistry conference. This is why just full stop. You should never listen to your advisor. Like I remember when I was in grad school, I swear this happened all the time. Like we'd just be humming along. Everybody's making progress on their projects. Everything's fine. And then our advisor would come in, we get back from a conference, we have a group meeting, and those are just the worst because he'd walk in and he'd be like, all right, everyone, I've just seen like 13 presentations. I had breakfast with all my friends across, different universities, and we all in this group need to immediately stop what we're doing and imitate everything that I just saw. Go into the lab and don't come out until our research looks like everything that I just told you about.
As if graduate students already had no ability to enjoy a second of free time. Now you have to get more data so your advisor can feel like he's just keeping up with his friends across the academic world. Plus, then you get more of these experiments, these troubleshooting where it's like, I've never heard of this molecule or experiment stuff. And then they call and we have to say like, all right, well, I have no idea why your experiment failed.
Yeah, exactly. And if Lisa calls and asks questions about her nickel, platinum, palladium, iron complex, I'm just going to be like, nope, let's just do something simple that's been done before.
Yeah. People want to know why their research doesn't work. And I have no idea, but I have no problem making up a million reasons why it's wrong. It's the one time explaining why you're wrong is a good thing, and they appreciate it.
I am just great at telling people why they're wrong. It's my favorite.
Okay, so we know that the electrochemical system is fine, and there isn't some kind of new science thing that we need to be worried about. And we know that a glassy carbon electrode in dilute sulfuric acid gives an interestingly shaped voltammogram within the sweep limits. So as you start to sweep anodically, it's pretty flat. Nothing's happening. And, we're using the IUPAC plotting convention. As we start to sweep anodically, it starts to curve up as we oxidize water. You've probably seen something like this before when the current starts to increase exponentially. However, when we change direction of the sweep before it goes too far, then it curves back down and flattens out. But there is a band between the anodic and cathodic sweeps. And then finally it starts to curve down where we start to reduce hydronium to hydrogen.
You mean reducing protons to hydrogen, right?
Seriously? Are we going to get all huffy about this? Technically, they are hydronium ions.
Yeah, Alex, how many people know what a hydronium ion is?
Same number of people who know what a proton is.
Yeah, that's precisely 0 people.
Okay, then. Well, what would you have me call them? Protons, hydronium, water, H+, weak Bronsted-Lewis acid-base conjugates?
Yeah, exactly. Yes, that is the. Please refer to the molecule that's reduced to hydrogen gas at low potentials as the weak Bronsted-Lewis acid-base conjugate. Now continue.
Anyway, as I was saying, we reduce the weak Bronsted-Lewis acid-base conjugates, formerly known as hydronium, to hydrogen. Again, similarly to how I described the anodic curve, that same kind of exponential decrease in the current, but we stop or switch the potentials before it goes too far. Overall, it looks like a long rectangle with pinched sides going on opposite directions, kind of like a big banana.
A banana? I don't know what the grocery stores or banana trees are like where you grew up, but this big pinched rectangle thing sounds more like an S. Bananas aren't shaped like an S.
Okay, so maybe like 2 U's back to back?
Maybe more like a C, right? Because the default shape of a banana is a C. Like you go to the grocery store, the bananas look like C's.
Right, so like the ground state of a banana is a C, not a U. It takes energy to move the banana into the U position. Now, all that said, the voltammogram looks a little bit more like an S, but then you wouldn't call it an S-shaped voltammogram.
Yeah, not that one, because S-shaped voltammograms are usually reserved, that like term, for like RDEs and microelectrode voltammograms, which are like steady state, and glassy carbon, in background voltammograms, you get this banana shape, which is, I don't know, I guess you'd say the closest human shape we have to describe it, but I don't think that's entirely accurate.
It's electrochemistry, so I guess this is par for the course. So the glassy carbon electrode response is supposed to be an odd-shaped banana. I think Lisa would have probably preferred an odd-shaped banana over the mess that she observed. Well, maybe not, because then she'd have to, that would open up a whole other can of worms. Like, why are there two anodic waves, especially when one's at the negative potentials?
Gosh. I think duck shapes are acceptable. Like, the duck voltammogram everyone talks about, right? Actual banana shapes, not acceptable.
It's probably in the paper somewhere.
Actually, now that you mention it, I bet someone's whole PhD was on like banana-shaped voltammograms.
So we are getting an oddly shaped banana voltammogram. Like, we're getting noise, and not even superimposed noise on a regularly shaped voltammogram. This is just straight up nonsensical, zigzagging lines all over the place, which makes me think that there's some kind of connection or potentiostat issue.
Right. So no bananas or ducks or anything else. We have banana mush. But, banana mush is a good indicator that there's some kind of connection issue. It's not working. And so at this point, I would, suggest to Lisa to use a dummy cell. And if you've never heard that term used or you've never used a dummy cell, it's not a stupid electrochemical cell. I'm not being mean here. It's actually quite the opposite. It's a very smart electrochemical cell. In fact, I would go as far to say that I wish all electrochemical cells were dummy cells because these ones actually work.
All right, can you elaborate on that?
I would love to. So a dummy cell is a simple electronic circuit, really just basic, right here with resistors and capacitors. I mean, you can just buy stuff like from Radio Shack.
Well, maybe not Radio Shack. I mean, does Radio Shack even exist?
That's a good question. Actually, I think they do, but actually whether you'd want to go to a Radio Shack anymore in the year 2023 is an entirely different question. But I'm just saying, like, you could go there and maybe you'd find resistors or capacitors, but like, are you going to want to go there? Or maybe you just want to order everything from Amazon or DigiKey. That actually sounds a lot easier. But anyway, the dummy cell, whether you're going to DigiKey or Radio Shack, is composed of resistors and capacitors, and you can actually just get away with using just a resistor. But the goal of this dummy cell is to have your potentiostat reproduce physics. So the simplest example is a plain resistor, right? You connect your potentiostat cell cable to either side of the resistor, and if you do like a cyclic voltammetry experiment, you should just get a straight line in accordance to Ohm's law.
Right. V is equal to IR. So you can get a measure of the resistance value from the slope of your straight line CV, assuming that your potentiostat is working properly and everything is obeying physics.
Yeah, but on second thought, obeying physics is overrated, so you should be a rebel.
Well, if your potentiostat is being a rebel and it isn't obeying physics, then it probably needs to be repaired. But I can tell you that in Lisa's case, the potentiostat does work. She did do a dummy cell test, and the potentiostat works.
Darn. See, I was hoping that it was the potentiostat because then I could just tell her, ship it to the manufacturer, have it repaired, and that's like not my job.
Yeah, so you are still technically on the hook. Sorry to say that. But Neil, what is the one electrode in any electrochemical system that never fails to cause problems and headaches in an electrochemistry experiment?
Ooh, I'll take the reference electrode for 600, Alex.
Bingo! And do you know why the reference electrode is the issue?
Because reference electrodes suck. They are why the dinosaurs died, they are the reason for the Black Plague, and they caused the stock market crash of 1929.
I didn't know those facts. How fascinating. Well, unfortunately, we can't get away from them since they're part of a normal 3-electrode experiment.
Man, what a drag. Can you please explain why I can't escape reference electrodes?
Well, first and foremost, the sole purpose of the reference electrode is to maintain a stable reference point in your electrochemical cell. If I could connect my cell cable to a coffee cup and it was stable in my cell, then I'd be using a coffee cup as my reference electrode. It'd be 0.2 volts versus coffee cup would be acceptable. And another thing is that potential is a relative quantity. So for all of you chemists who are listening, you're probably used to units like kilojoules or electron volts, wave numbers, and all of those have like an absolute value. But potential is always between 2 points. Even if you take your wall outlets like 240 or 120 volts coming out of your wall, well, that's 240 or 120 volts versus ground. And while it's not stated explicitly, it is there. In an electrochemical cell, your working electrode potential is referenced with respect to something. Or you'll see in the publication versus reference electrodes like silver chloride, as in the case with Lisa. There are a myriad of different reference electrodes that people use depending on the electrochemical system in question. But the bottom line is that the reference electrode must be stable.
So I was only like partially listening to everything you just said, but all I know is now I want another cup of coffee.
You mean like some kind of mocha frappuccino? I don't drink coffee, so I don't understand coffee drinks.
Yeah, that's not a thing. But, as I think about that glorious 7 months I spent at Starbucks after my grad classes were over, I just remember all the lattes and the cappuccinos and the mochas. And then I learned about yummy stuff like cold brew and oat milk and Irish cream and peppermint.
But I actually don't think people really like coffee because they add so much other stuff. Like at some point, you just have like sugar.
As our resident coffee expert, I should be offended, but actually, I think you've probably got a point there.
So maybe Lisa's like sugar and cream to coffee ratio was off that morning. So as I was saying before, you need a stable reference electrode to get good electrochemical data, something like silver chloride or calomel, but it might be different for various kinds of experiments. But the key is that it's got to be stable.
Wait, slow down. Are you trying to tell me that the reference electrode is stable?
I think I'm trying to say that the reference electrode needs to be stable. Yes.
Okay.
Yes.
Okay, good. Because I wanted to make sure that the reference electrode should be stable. Like I don't think that was clear. I'm just checking.
You know what? That's a good point. That's a good point. Let me read it. I'm just trying to say that the reference electrode should be stable.
Okay, so you're saying that the reference it should be shifting around and like unstable.
No, it should stable.
Oh, wait. Oh, okay. So you mean not unstable?
Stable.
Okay. I think I got it now. Wait, are you ready? Tell me if this is the right statement, right? The reference electrode should be stable.
Yes, that's the right one. The reference electrode should be stable.
Oh, whew. Okay. Thank you for confirming. But just word of advice, next time, please just be more clear from the beginning about what you mean. You really need to like stipulate what you're trying to say. No need to cause so much confusion.
You know what? That's my fault. That's my fault for sure. So Lisa is using a silver chloride reference electrode. There's a few important points about electrodes that we need to discuss. So first, hopefully, it has a stable reference potential, which is based on the concentration of chloride ions that are inside. And if you're wondering why that is, I would encourage you to look up the Nernst equation. It basically it's governed by that expression. Also, it has a frit that acts as a bridge between the inner fill solution, which is usually potassium chloride, and the main electrolyte. In this case, it's dilute sulfuric acid. Since we're focusing on the reference electrode as the most likely reason why Lisa's glassy carbon electrode surface looks like that asteroid from the movie Armageddon, we might say one of those things that I just mentioned could be causing trouble.
Wait, so I am interested in figuring out why, whether the internal fill solution concentration or the frit or something with Lisa's reference electrode is the root cause, just like you are. But first, did you just reference late 90s Bruce Willis movie Armageddon?
I sure did. You know that part when they first land on the asteroid and it's just a bunch of black mountainous caverns with spikes coming out of all over the place?
Oh yeah, and they drive that cool dune buggy thing all around it. Oh, this is some great nostalgia. Hey, fun fact, they actually filmed that scene on one of Lisa's destroyed glassy carbon electrodes.
Oh really?
Yeah, they took Lisa's electrode, they shrunk everybody down to fit on the electrode, with the dune buggies and everything, and they used the Hollywood shrink ray, and then they shot the scene.
Oh, yeah. I heard about the shrink rays that they've been using in Hollywood. That's right. You know what's funny? I love how when a shrink ray doesn't work in a movie, it does exactly the opposite of what a shrink ray does. It makes things bigger.
Yeah, right. They don't just not work, right? If a shrink ray didn't shrink people down, it doesn't just leave the target the same size.
Exactly. Like any other device, like a coffee machine doesn't spit out tea if it's not working, or a barbecue pit doesn't just produce vegetables when it's not working.
Or would you say does the average grad student actually make a PhD?
Oh, shots fired.
Yeah, exactly. Get it? See, I insinuated that graduate students don't work. See, that's a PhD level dad joke.
It's okay. I always enjoy a terrible dad joke. But back to Lisa's reference electrode. Is it the frit? Is it the fill solution? Is it small gremlins living inside the electrode, sabotaging the silver wire?
Honestly, I'm quite fond of the tiny gremlins theory myself.
Me too, though I guess it's probably unrealistic. But if you think about the frit, for example, if it gets clogged, the communication will be interrupted because there'll be no ions that can make it its way, from the internal fill solution to the main electrolyte. When this happens, it's as if the reference electrode wasn't connected to the potentiostat and the cell. And if the reference electrode is disconnected from a cell, it disrupts the feedback circuit of the potentiostat. So without going into too much detail, a potentiostat controls the potential by driving current through the counter electrode. I think of a potentiostat like driving a car. You're trying to maintain a safe distance between you and the car that's in front of you. And all you can do as the driver is you can accelerate or you can slow down to maintain that safe distance between you and that car.
Well, that sounds ridiculous. All I ever do when I'm driving is accelerate, okay, so that I can close the distance between myself and the cars around me and wherever I'm going. I want to get there faster. And I have no interest in keeping a safe distance between me and anybody. So I don't think I understand your analogy at all.
So if you were a good driver and you're watching the road, you'd be adjusting the brakes or accelerator as needed. So in this analogy, potential is the distance between the cars. Your eyes act as the feedback loop, and the brakes and accelerator is the operational amplifier, which basically amplifies the signal. When the reference electrode is disconnected, it's as if you put a static picture of a car on your windshield. So no matter how fast you drive, you can't close the distance between the car that's in front of you because you're looking at a static, non-changing picture. So you slam on the accelerator trying to catch up to that car, but you're really crashing into the car in front of you. And in the electrochemistry world, disconnecting the reference electrode forces the potentiostat to drive as much current as possible between the counter and the working electrode. Even if it's for a short period of time, your working electrode might have several amps of current flowing through it, oxidizing and reducing all kinds of stuff on your electrode. And ultimately, that changes the macroscopic picture of your electrode.
So you're saying if there was a blocked frit or, some other interference with the reference electrode, it would mean that the potentiostat is operating the way that I drive, and this could explain, I guess, why Lisa's glassy carbon working electrode got just destroyed, with, some surge of current.
Exactly. So the question is, how exactly did the frit get clogged? Or how did the reference electrode get disconnected somehow?
Yeah, so Alex, I actually have some news for you on that point.
Oh, yeah?
Yeah, see, you remember in the beginning, I guess setting up Lisa's, problem, you were talking about everything. You said that, she got her experiment ready and she did all the things, right?
I do, yes, but where are you getting at?
Well, actually, there's one piece of information that I have to fill you in about here. So see, Lisa, she actually just forgot to connect the reference electrode line of her potentiostat cell cable to the silver colored, right? Like it wasn't a blocked frit. She just fully disconnected her reference electrode. Yeah. That's kind of a bummer.
So after everything we just talked about trying to figure out what happened, she just forgot to connect the reference electrode.
That is correct. So, everybody, the lesson here is make sure you connect all of your electrodes before starting your electrochemistry experiment.
Well, in that case, yeah, that's right. And I would say it's a case closed. Well, folks, I hope this story was both entertaining and helpful for you, and hopefully you'll enjoy our next segment. But first, a word from our sponsors.
Hi, Pine Research here for the MSR Electrode Rotator, your one-stop shop for RDE electrochemistry experiments. Ordinary rotators get stuck, don't rotate, tie your hair in knots. The MSR goes to 10,000 RPM and is certified dolphin safe. Can do rotating disc, rotating ring disc, and rotating cylinder electrodes. You got aqueous solvents, it rotates. You got non-aqueous solvents, it still rotates. I've got this bucket of sludge from some lab, I don't even know where it came from, and it still rotates. The secret is the patented spindle winding technology that transfers all the torque bending force into the electrode, generating gigabytes of electrochemical data instantly. Don't waste your time with those run-of-the-mill generic rotators. You need the sludge-busting power of the MSR electrode rotator. Call your purchasing department today and get them to do whatever it takes to get yourself a brand new MSR rotator in your lab today.
Advertisement is a joke for comedy purposes and is not real, nor does it constitute an offer of any kind from Pine Research. Restrictions apply. See terms and conditions for details. Not valid in Alaska, Hawaii, any of the contiguous 48 states, or any country on any of the 7 earthly continents, except Antarctica. Contact Pine Research for details, real offers, life advice, or product quotes.
Hey folks, it's time for a little game of Password Electrochemistry Edition. In Password, Neil and I have each chosen 4 passwords each. It's our job to give each other a hint to have them correctly guess the password. The password has to be one word, and the hints also have to be one word as well. We are trying to guess each other's password in as few hints as possible. These 4 passwords have an overarching electrochemistry theme that we have to guess at the end of the game. So, Neil has 4 passwords I'm trying to guess, and I have 4 passwords Neil is trying to guess. And once we know all the passwords, we need to guess the electrochemistry theme. All right, are you ready?
Oh, I'm so ready.
Okay. Which one of us is going first again?
Yeah, why don't you go first?
Okay.
You give me...
I'll give you the hint. All right, so...
The password is coin.
The first password, this is the hint. Bit.
Let's see. Data?
No.
Okay.
The second hint?
Yeah.
Okay.
Yeah.
All right. Money.
Oh, man.
First one was bit.
Bit and money.
Yes. Bit and money.
Rate? No.
No.
Oh,
Okay.
Man,
okay.
This is hard.
This is
This is hard.
This is hard. This is guys. Okay. All right. Circle.
Bit, money, and circle.
Mm-hmm.
I have to only say one word.
Yes, one word
Yeah.
that's related to these 3 things. Do you want another?
Yeah, give me a different hint.
Okay.
I don't know if you want.
Crypto.
Currency.
No.
What? How is that not the answer?
Okay.
Oh, wait.
Yeah.
Okay. Well, I guess, give me another hint, because that was my answer.
I mean, I'm writing down all the hints.
I think I know what it is now.
Well, okay, you can still.
So can I still guess?
Yeah, you can still guess.
Coin.
Yes, that's right. All right, good, you got it.
God, that should have been easier.
Password.
Yeah, bit. When you said bit, all that I could think of was like
data.
Yeah, bit
Stuff like
rate.
that.
So I'm on the wrong.
Bit rates and
I'm on the wrong.
it's all good. It's all good.
The wrong
all right.
wavelength there.
Okay, all right.
Gosh.
So we got.
So coin is your first password.
Yes.
Got it.
Coin is my first password.
All
All
right.
right, now it's your turn to.
All right.
tell
Here
me
is
something. All right.
your first.
The password is polar.
My first clue for the first password.
Okay.
Bear.
All right, bear. Now I want to say market, like bear market, but that can't be it. That can't be it. Roar.
No.
No.
Okay. Okay. Here's your next clue.
Okay.
Ice.
Oh. Black.
No.
No.
But I think you're thinking in the right way.
Black bear, black ice. Okay. Maybe I'm not thinking in the right way then.
Okay. All right. Your third clue.
Uh-huh.
Frigid.
Frigid. Okay, so wait, bear, ice, frigid.
I have a different guess if you or a word I can try.
Because I'm thinking like ice and frigid. They seem
they're similar.
They seem very similar.
All right, let me give you a different
hint.
Yeah.
Okay.
Considering the first 2 I gave you, which was bear
Uh-huh.
and what, ice?
Yeah. Bear
Right.
and ice. So bear,
Ready?
ice, frigid. Okay.
White.
White. Okay, I feel like polar.
Yes.
Polar. Okay.
Yes.
Yes.
This is harder than I thought it would be.
Oh yeah. All right. That took me. Okay.
Yeah.
Polar. Oh, that's
Okay.
Good. That's good.
So your first word is polar.
Yeah. So my first word is polar. Okay.
And my first word
That's
was
my first
coin.
password.
I'm actually marking down coin. All right. So
Yes.
give me my second password.
The password is wedding.
Okay. The second password clue is marriage.
Ooh. Certificate? No. Okay.
No.
Yeah. Wrong wavelength.
It's okay. It's okay.
Yeah.
All right. I think this one will get. I think this one you'll get. Party.
Wedding.
Yes.
Wedding. Yeah. Only
Wedding.
two.
Only
That's pretty
two.
good. That's pretty
That's good.
I'm
Okay.
impressed with myself.
Okay. Yeah.
Okay.
Now I have to try to impress.
Yes. Okay. Those were good guesses. I mean,
Okay.
good
Good, like,
password
hints.
hints. Yeah.
Password hints.
I'm not sure my hints are going to be all that great. A coin in wedding. Interesting. I'm trying to figure out what the theme is eventually. Okay.
Yeah. It might take a little bit of a jump of it.
thinking.
I think the next two will be a little
see.
more helpful.
Okay.
A little more.
Perfect. Well, you'll get yours too eventually, I hope.
Yes.
All right.
The password is cold.
Your second password clue is chili.
What's with the cold theme, man? Frigid ice, chili. Okay. Chili, but maybe you're not thinking about that chili.
Sorry, should I spell it? Because actually, that's a homophone, right?
Yeah.
Homonym,
yeah.
homophone. What
Yeah,
what is-
because I'm trying to think.
Yeah,
it's either-
I'm actually not talking about the country or
okay.
the food.
Or the food.
It's chili as in CHILLY.
Oh, okay. Because
That is the word I said. Yes.
Because I did think about the food first.
Yeah, or the country.
Or the
Those are
country.
not the ones I'm talking. I'm
Yeah,
actually the
that's-
word chili with a Y at the end. Yes.
Yeah.
To be
that's
clear.
right, with a Y at the end.
Yeah.
Okay. And then the first password's polar chili. I want to say, let's see, shiver.
No.
No. Damn, okay.
Let's see here. So your second clue is frigid.
Second clue is frigid. Okay. Second clue is frigid. So shiver. Okay. So and I know it's not shiver. So chili, and these ice themes. And frigid. Okay. So everything's like a cold theme now. Frigid and chili.
Don't overthink it.
Cold?
Yes.
Oh, cold.
I'm like, should I give it to you? You said cold theme. Like, that's the word.
That's the word.
Yeah,
Okay.
exactly.
Okay,
Yes, cold
okay,
is your second word.
Cold is the second. Okay,
Yeah.
cold. All right.
The password is spin.
All right. So the next password clue, and well, let's see if you can pick up on this one. It's specific to you. It's my only hint.
Wow, this is interesting.
Okay. Name.
I mean, it can't just be my first name or my last name, maybe. Maybe it is.
Maybe it is.
Name. And it's specific to me. Spinner?
Very close. Just like
Spinning. Give me another clue.
well, no, I mean
is that the only clue you can give me?
I mean, it's like you're on it. It's another word for
rotate.
well, no, it's the
Is it like a different form of that
it's a
word?
different form of that word. Like
spin.
yes.
Oh, okay.
Spin.
So, yeah,
I didn't know a better way of doing
Yeah,
it.
that's like a conjugation problem.
conjugation.
Exactly.
I should have said,
yeah.
Then the next time it would have been conjugate. Okay, well
That
that was
makes
good.
sense.
You got it.
Yeah. All right. So I got coin, wedding, and spin. This is a strange couple of words, few words here.
Yeah.
I have to see the last one to see which electrochemistry theme it is.
Yes. Yeah. I think it'll make sense. Hopefully the last one makes gives it a little more.
Yeah, I think so.
A little more.
Hopefully, we'll see.
Hopefully.
All right.
The password is continent.
Yes. Okay. So here's your third password clue.
Okay.
Asia.
Asia.
Yeah, do you remember that?
I forgot what that's from.
That's Celebrity Jeopardy from Saturday Night Live. It's like, name the continent heard here. Asia.
Yeah, that's right.
It's like, that's the clue.
Asia. Okay. Asia. Russia?
No.
No. Okay.
All right. Next clue.
Next clue.
Europe.
Oh, countries?
No.
No. Oh wait, no. Well, I mean continents.
Is that your
That's
hint?
what I meant to say.
Yeah,
I meant
yeah.
to say continents, but what came out of my mouth was countries.
Yes, continent is the answer. I think that's what you meant to say.
Yeah.
That
Sorry.
seems pretty.
Thank you.
evident. Yeah.
This is very lenient password.
Yeah, it is. Yeah, this is like password if everything's made up and the points don't matter, right?
Yeah, that's
like,
right.
what was it? Whose line is it anyway?
Oh yeah,
That's
right. Okay.
The password is twister.
The last password clue for the last password. The clue is tornado.
Vortex?
No. Okay. Close. Okay. Typhoon.
Oh, these are like storms
Yeah.
that rotate because spin. I mean, there's got to be something about the cone. It's a cone. It's a like
Well, maybe
like a funnel.
Yeah. Yeah, there's another actually okay, I have another. Maybe I shouldn't. I'm rethinking my hints to you.
Okay. Give me one more hint.
Okay. Movie.
Twister.
Yes.
Yeah.
Twister. Yeah. There we
that's
go.
it, Twister.
Twister.
Oh, that's good. That was an easy one.
Okay. We're getting the hang of this.
Okay. So, should I guess? We should guess themes together afterwards.
Yeah. We can guess themes.
So
together.
I've got coin, wedding, spin, and twister.
Yes.
Okay. And what are the words that you've got so far?
I've got polar, cold, and continent.
Okay. So are you ready for your last one?
Yes.
All right.
I think.
The password is south.
Your final password clue. Direction.
North?
No.
No. Okay. Direction.
Your second clue. East.
Okay. Direction east.
I shouldn't have said that. Now I think I'm throwing you off, actually.
Um,
Forget it. Expunge it from the record.
Expunge it from the record. Okay, not east. Different
Okay.
hint.
So forget I said east.
Okay.
Okay. So you said direction. All right. I'll give you another clue. How about that?
Okay. Another hint.
Down.
Direction down. And a not hint east.
I mean,
But
yeah, this is a very
down.
loose definition of password.
this is a
of
very
the
loose
game.
definition of password.
Whatever we want.
Yeah, okay. You said direction and then down.
Yeah.
South?
Yes.
Okay, south.
Yeah. I thought
Okay.
east would make you start going like, yeah.
Yeah,
I'm
at
trying to
least
think like
within
how to
those-
guess. How do you not say anyway?
Yeah. Oh yeah. Okay.
I figured if I just said north, east, and west, eventually you would get south.
Yeah,
So I was
eventually I
like,
would get to
what's left?
It's like-
Yeah.
No. Okay. All right. That was good.
Yeah.
Okay. All right. So now we're at the point where we need to try to guess each other's
Electrochemistry related theme.
electrochemistry related theme.
Yes.
Okay. All right. So you have coin, wedding, spin, and twister.
Yeah.
It's an electrochemistry theme. If it's any hint, you actually said a lot of words that it's like if that was the word, it'd be super obvious. Like it'd be
Right.
super obvious. So I had to make the password like related but not quite but not quite that. I would.
Well, spin and twister sounds like a rotator thing.
Mm-hmm.
And coin is like a disc. So is it, I mean, I don't know what wedding comes from, like how this plays in, but I'm guessing, is it RDE?
Yeah, RRDE.
RRDE.
Yeah.
So what's the wedding?
Wedding, I just thought of wedding and rings, because that's where you
it's
exchange
a
rings.
ring. Oh, that's good. Yeah, there we go.
But if I put ring, then it's like...
Right, so coin is disc,
Coin is
wedding
disc,
is ring, and then it's spin and twister. For the...
So actually, when you said vortex, like... Because I was thinking about creating a vortex in solution, and spin is just rotating.
Yeah,
I was thinking about another word for another word for rotate is spin, it creates a vortex. Let's do a twister, and there is the wave vortex rotator, so it's just kind of like, that might be a little
shameless plug.
Shameless plug.
Yes, that's why I thought of the word.
Obviously. Okay.
All right, so your turn to guess the theme.
Polar cold continent south.
That's right.
Electrochemistry theme.
That's right.
Okay, so let's see. Okay, maybe maybe we have like, when I think of south, I was gonna say like Russian. Maybe it's also an RD. Like maybe it's like Levitch or something like that.
It's not.
It's not Levitch.
No.
That would have been like, it's cold, but then he moved. No, he didn't move to the south. Because really, it only reminds me of like a country, like a continent, like Antarctica or something.
That's correct.
That's correct. Wait a minute. Maybe what kind of electrochemistry theme is this?
Oh, it's not.
Oh, it's not. Oh, you
No. I just didn't follow the rules at all.
It could have been the only continent where there is no electrochemistry.
That's roughly true.
That's
but
roughly
in
true.
my research on Antarctica, there's somewhere between 1,000 and 5,000 people that live there, or at least seasonally, probably doing research.
Really?
And things.
Oh.
Yeah, like I think they probably cycle in and out to do research. There might be one electrochemist in
There
that
might
group. You don't know. That's what I'm saying.
Out of 5,000 people.
Yeah, is one out of every 5,000 people an electrochemist? I doubt it.
No.
No,
I'm just gonna say that right now. Like people have these statistics about, like, if you're in a crowd of 100 people, you're probably gonna have multiple people with the same birthday. So it's like, if you're in a crowd of 100 people, how many of them are none?
Zero.
Zero.
Absolutely zero. Unless that crowd of people is at an electrochemistry conference.
Yeah.
Then all of them are.
Then all of them are.
But
yeah,
otherwise, that's right. Yes. This was Password Electrochemistry theme, and I just decided not to follow the rules. So you're welcome.
But that was fun, though. That was fun.
That was harder than I thought it would be.
And I thought polar. I was just like, polar. Okay, all right.
See,
maybe
I misled you. Like polar coordinates. Nah, it was just Antarctica.
It was just Antarctica.
That's right. The big hunk of ice at the south of our planet. That's right. That's it. That was all it was. I misled you.
And I made things really complicated to get to RRDE.
That was cool, though.
That was good.
That was cool.
We'll play this game again in a future episode of the Electrochemistry Podcast. This was fun.
Yeah.
This was fun. All right, folks. Well, I hope that you enjoyed this game and the first episode of the Electrochemistry Podcast, and we'll see you soon.